It's my pleasure to introduce Dr. P. Shanmugam sir, Chief Scientist and Head of the Department, Environmental Science and Engineering, CSIR, Central Leather Research Institute, Tamil Nadu, where he is leading the team of scientists and young researchers to carry out the research in the field of sequential production of biodiesel, bioethanol, biohydrogen, biomethane, and solid waste management. Initially, he worked as a scientist in the Environmental Air Pollution Division of CSIR Central Road Research Institute, Mathura, Agra Road, New Delhi. And later, he transferred to the Environmental Technology Division of CSIR Central Leather Research Institute in Chennai, where he is working in the tannery, effluent, and solid waste management using the low-cost zero liquid and zero solid waste management systems for tanneries coupled with the municipalities. He is the full-time honorary professor and recognized PhD supervisor in the Center for Environmental Studies, Department of Civil Engineering in Anna University, Chennai. He already supervised 5 PhD students and 2 are ongoing. He has been teaching the various environmental engineering courses for Masters in Environmental Engineering and Management Studies in Anna University, Chennai. He is teaching membrane separation technologies for water and wastewater treatment, air pollution modeling and control, environmental impact assessment, solid and hazardous waste management. He has completed his PhD from the School of Civil Engineering, University of Leeds, United Kingdom, on Commonwealth Fellowship after his master degree in IIT Madras. He is the chairman of BAT, Best Available Technologies Entailing the Lower Cost, for the Environmental Protection Central Board for Pollution Control Board and Ministry of Environment and Forest, Government of India, New Delhi. He is a member of Indian National Bioenergy Board, National Master Plan for Bioenergy in India High Level Technical Advisory Committee in Department of Science and Technology, Central Pollution Control Board. He is also a member of Bureau of Indian Standards Committee for developing Indian biogas standards on selection of small and large scale biogas equipments in MNRE, Government of India. He is the advisory member for Tamil Nadu Pollution Control Board for preparing the state level environmental policy. He has been the reviewer for the 8 international journals in the environmental engineering. He is the member of Board of Studies for the curriculum development for the various institutes, Center for the Environmental Studies in the Department of Civil Engineering, Anna University, Environmental Engineering, Department of Civil Engineering, the National Institute of Technology, Tiruchirappalli, PG Research Department of Environmental Science, Bishop Heber College, Bharati Deshan University, Tiruchirappalli. He has been awarded with the several awards. Peter Wilson Award offered by the British National Fuels Limited, member of Chartered Institution of Waste Management, UK, Commonwealth Fellowship for PhD by British Council UK in 2005, UNDP GEF Fellowship for Anaerobic Digestion Training in European countries during the 2000, International Conference Grand Award for WHEC Australia Royal Academy of Engineering UK. He recently awarded with the Dr. APJ Abdul Kalam Memorial Award by Government of Tamil Nadu. He has his credit over 100 publications, peer-reviewed international journals, and 15 patents. He is also honorary full-time faculty in the Anna University Center for Environmental Studies, Chennai, teaching for undergraduate and postgraduate environmental engineering students on wastewater engineering and treatment for disposal of membrane separation process. He has also been core member of CLRA, Chennai, in implementation of large-scale biogas plant with a maximum biogas production capacity of 5,800 meters per day. It's my honor to welcome Dr. P. Shanmugam sir. Over to you, sir.
Okay, very good morning to all of you, indeed. I'm unable to connect this camera. I'm just doing simultaneously. I hope Dr. Premalata Madam is here.
Sir, I think Madam has a class.
Okay.
So she is.
Fine. Thank you very much. Thanks for inviting me for this ATAL program. The today topic that I'm going to talk to you about is municipal and industrial solid waste management through the sequential production of biodiesel, bioethanol, biohydrogen, and biomethane, a biorefinery concept for waste into wheel. Why I say here waste into wheel, you all would have heard about waste into energy, that is waste into electricity. And then the next program was waste into cooking fuel, and waste into wheel, when I say it is waste is converted into biogas or biodiesel or bioethanol or biohydrogen. blended together or individually as an alternative fuel, alternative renewable fuel, we could feed into the automobiles. The wheels of the automobiles can be operated, and that's the reason I kept the concept as waste into wheel. So the waste is used to produce the biofuel, and the biofuel is used to operate the wheels of the vehicles. That's the reason I kept waste into wheel. When I say waste into wheel as a biorefinery concept, and this is what I tend to say as a biorefinery concept. The waste is reduced, recycled, or recovered. This is the R cube concept of reduce the waste at source, recycle the waste maximum possible. That's called a resource recovery, and recover the waste. And the recovery of the waste means not the recovery of the waste and recovery of resources. The resources could be anything as biofuel or biogas or any kind of alternative fuels. That's called recovery from the waste material. The existing technology being followed is burn it, which is an incineration process. Bury it, which is a landfilling process. Bury it and put it and close it, and that's a landfilling process. It's a colloquial form of saying that bury. And bug it, bugs or the bacteria or the enzymes, bugs. You give it to the bugs of the organic waste. The bugs can convert into biofuel. That's if it's an enzymatic route. If it's a chemical route, we don't bother about the bugs. If it's a physical route, we don't bother about the bugs. But ultimately, what I'm trying to convey, bugs are the biofuel. Bugs converts the waste into fuel, that becomes a biofuel. And the biofuel technology becomes one of the attractive alternative comparing to any other chemical production or thermal production or pyrolysis or any other method of producing the fuel. Once you use the bugs to convert the waste into fuel as a biofuel, we could produce energy out of it, out of the biofuel, and we could save economy out of the waste material, and we could also protect the environment. And that's the reason I call it reduce, recycle, burn it, bury it, and bug it, and energy. Could you please mute hello? Could you please mute? If the organizer can mute the other people's thing, please.
Yes, sir. Yes, sir.
It will disturb.
Yes,
Organizer,
yes,
please
sir.
take
Okay,
care
sir.
that
Yes,
there
sir.
won't be any interruption in between.
Okay, sir.
Yeah, so when you say that's a reduce, recycle, recover, burn it, bury it, and bug it, and to get an energy, economy, and environment, and these are the concept of the technology that I have been following. You can take the waste contain a lot of fat material. You can, because most of the waste, organic waste particularly, it contains protein, carbohydrate, and fat. If the waste contains fat, particularly dairy waste, slaughterhouse waste, leather waste, tannery solid waste, and most of the waste cooked hotels cooked oils, and if the most of the waste contains fat content, that could be converted into biodiesel, that could be converted into biodiesel using a transesterification process or an enzymatic transesterification process. And then the same solvatogenesis process of fermentation can convert into an ethanol process. You know, the ethanol production from the molasses is a very age-old process. But here, can we convert the saccharification method of what an ethanol being produced? A little bit, I have modified the process of saccharification and convert the organic solid waste fermented soup of acetic acid, ethanoic acid, and butyric acid, and propionic acid also together convert into ethanoic acid. And that ethanoic acid has been converted into ethanol using the same fermentation process, but a modified seed inocula. And then I use the same fermentative process for the hydrogenesis process to produce hydrogen. It's a fermentative hydrogen. We call it as a biohydrogenesis, producing hydrogen from the same waste material. And the residue comes out, then finally we produce methane. You might ask me why we should go for 4 fuel technology, producing technology instead of 1 fuel. Because you all know the leather and the industrial solid waste have achieved zero liquid discharge system. Liquid waste material have achieved a zero liquid discharge system. Similarly, we also need to achieve a zero solid discharge system. So therefore, to achieve the zero solid discharge system, the multiple fuel production is imminent instead of going for a single fuel, because the residue the fat is recovered, the protein carbohydrate is, if it is high, the carbohydrate could convert into bioethanol. And the residue of the carbohydrate and the fat put together, it can be converted into hydrogen, it can be converted into methane. Finally, after you convert 4 fuels, the residue contains very good rich nutrients, and that can be used in the filter press and convert that into a very good agricultural manure and fertilizer, and that could be used in developing potato plants, tomato plants, and so on. So therefore, the zero liquid, this or similar to that, we could achieve a zero solid discharge. So therefore, finally, these fuels, the biodiesel can be blended with the original diesel and be used in the cars and buses and automobiles. The bioethanol can be used in the automobiles, and the hydrogen can be blended together with the methane and can be used in automobiles, or separately also can be used. And the methane can be again used as a compressed biomethane. Probably you all know many cities in India, we have demonstrated a lot of compressed biomethane plant. And that compressed biomethane plant is after purification of the biogas, and we enrich the methane by eliminating the carbon dioxide, and that becomes equivalent to a natural gas, like a compressed natural gas. It becomes compressed biogas. So therefore, this is the R cube into B cube into U cube concept that I have been demonstrating. We are looking for any organic waste, it emits a lot of carbon dioxide if it is completely degraded or completely combusted. When it is completely degraded, it is only very less quantity of carbon dioxide is released in the aerobic or in the anaerobic system. But when you are combusting in any automobiles, if you completely combust it, the end product is carbon dioxide. You might ask me a question, sir, we are ultimately efficient combustion leads to carbon dioxide. Inefficient combustion leads to carbon monoxide and unburned hydrocarbon, which is toxic to the human being. And this is the primary pollutant, and CO2 is the secondary pollutant, creating a lot of global warming impact, a lot of sea level rise, a lot of tsunami kind of a problem. And which pollutants we must give importance to control it. Whether we must efficiently have a combustion process to release a lot of carbon dioxide, or we must have an inefficient combustion process. I would say the efficient combustion process always leads to CO2. But if you look at the carbon footprinting, carbon clean developing mechanism, and so on, the CO2 also is one of the dangerous gas these days on climate change potential that need to be mitigated. And therefore, we should also focus into carbon neutral technology. Any solid waste management technology that we are going to have it, we must have an efficient combustion, no doubt about it. We must have an efficient utilization of the organic matter, no doubt about it. But at the same time, we must also look into a carbon neutral or carbon negative technology that only can save the future from the global warming, from the greenhouse gas emissions, from the tsunami kind of a problem. Therefore, we must have a carbon neutral technology, whichever the technology, either it could be a biodiesel or biofuel or a bioethanol, or biohydrogen or methanol economy, or any kind of fuel production from the solid waste. We must look into a carbon neutral technology. That's the reason I'm bringing down here. So how do you select the solid waste management or the wastewater treatment, on what basis? So normally, which is the prime focus that you would develop the waste management system is to achieve environmental compliance alone, not only to achieve that. For revenue generation, is it only for revenue generation from solid waste management or wastewater treatment technology? Not only that. There are PPP mode of the solid waste management these days, because the electronic waste, the biomedical waste, and the organic solid waste, all these waste have become a wealth, have become a rich revenue generating material, raw material. As a consequence, there are a lot of companies who have come forward to put it up as a public-private partnership mode in these days. But I wouldn't say so. The PPP is a public-private partnership, but we must attempt to PPP as a profitably preventing pollution. So how do we prevent the pollution in a profitable way? So what is more important is the profitably preventing pollution is more important than the public-private partnership. So we must look into what is the revenue-based waste management system. We must look into what exactly a revenue could be generated from each bit of the waste. Then only the waste management system could be attractive, and people will definitely follow it. because as a part of the management policy, we have a water tax and we have an air pollution tax for industries, and we also going to have solid waste tax as a part of the cess tax. So if we are going to have a solid waste tax and every citizens are responsible to manage the solid waste of what they generate from their home or from the hotels or from the vegetable market complex, they are responsible, or from the colleges or from the universities or from the any academic or research institute, from the canteen, from the food waste or the hotel waste, they are liable to manage their own waste without emitting a lot of CO2, without contributing to the climate change, without contributing to the air pollution problem, and without contributing to the groundwater contamination upon open dumping of the solid waste. So therefore, we have the prime responsibility of profitably preventing pollution should be adopted, that technology to manage zero carbon emission and to achieve carbon neutral or carbon negative technology, and to reach the maximum clean developing mechanism, maximum renewable obligation certificate, maximum carbon footprint, and maximum carbon offsetting, and that should be the ultimate aim through waste into wealth, or waste into electricity, or waste into wheel as a bio-CNG or bio-ethanol or bio-hydrogen and so on. So therefore, if you look at it, the natural greenhouse gas effect, that's what, when you do an open dumping of the waste, what happens? This waste, when it is putrefied, there is a lot of fugitive emissions of CO2 is being released. So that unaccountable fugitive emissions of CO2 becomes a big culprit for greenhouse gas emissions. You look at it, every city has got a mountains of waste being dumped over there. When the rainy season, it is wet and the bacteria comes in contact, it gets degraded and it emits a lot of carbon dioxide and the greenhouse gases to the atmosphere. That's what, as a consequence, we got into a greenhouse gas effect. And you look at it, these solid waste also create a groundwater contamination, because every cities in India, or may probably in the world, and we are all drinking this distillery water in everybody's home, most of the urban dwellers. Why we are so? What happens after a few years if there is no mineral water available, there is no RO plant available? Which water we are going to drink if we already pollute the groundwater because of the open dumping and leachate of the toxicants from those open dumped waste into the groundwater, and that groundwater is contaminated, and after 10 years, and it becomes a serious problem of the groundwater resources if we don't protect ourselves by through a bioremediation of the leachate or bioremediation of the contaminated land or bioremediation of this open dumping of the contaminated land. In every city, there are almost acres and acres of open dumped landfill sites are to be reclamated or to be remediated to protect the groundwater contamination problems. So therefore, open dumping is not the solution, and open dumping releases greenhouse gas emissions. Open dumping releases groundwater contamination, and open dumping also leads to odor and other pollution problems and other dengue-related, virus-related problems in the city. So therefore, it is important to achieve non-open dumping based solid waste system, at least in the near future. So when I say that how the greenhouse gas emissions are contributing to the climate change, because when these greenhouse gases are emitted, you know very well, and these gases trap the organizer, you are kindly requested to mute the phone, mute the people's audio. The organizer,
Yes, sir.
please mute their phones because it's disturbing me in between. So these are the pollution problems. These are the pollution problems due to burning and greenhouse gas emissions. Of course, you might see whether India is facing the greenhouse problem or not. You might see why the frequent natural calamities are occurring, particularly in Chennai. Every December, there is a flood in Chennai. Every December or on this period, there is a earthquake in the Indonesia. There is a tsunami problem, tsunami warnings. And why that is happening so frequently in the recent past, it's all we, the intellectual faculties, intellectual professors, we all have to think over, and we all have to formulate a technology to mitigate the global warming and to mitigate the greenhouse gas emissions, and also to mitigate the tsunami problem. Probably you all might, even I do understand tsunami and the earthquake is a natural phenomena. But a very meager point of the percentage, we tend to link the tsunami would also be presumed to be a natural calamities, presumed to be climate change related issues of tsunami, because the occurrence in the recent past become very frequent, which did not happen so, and hypothetically, and we have not been proved why this climate change are totally related to the tsunami problem. I feel so. Whenever the climate change happens, whenever the greenhouse gas emissions are exorbitant and the global warming takes place, it as a consequence, it warming up, it melt the frozen ice in the Arctic and the Antarctic. And the frozen ice increases the sea level volume, sea level rise. And the sea level rise is increased abnormally beyond its standard hydrogeological balance. And the hydrogeological balance become imbalanced. And that hydrogeological imbalance, because of the sea level rise, because of the melting of ice, because of the global warming, and because of the exorbitant emission of greenhouse gas emissions, becomes the imbalance in the earth, becomes particularly in the middle of the sea, becomes a cause for the tectonic zone movement at the mid of the sea, cause earthquake. I don't know whether it's a natural or it's a man-made because of the climate change. There is no proven data, but presumably, hypothetically, I feel so because of the recent incidences happens in the past 6 to 7 years, continuously the tsunami and the flood, because this year Chennai had a very bad flood. And last year there was, and year before last there was. Since 2016, we have been, Chennai is facing the problem of the flood and continuously, consequentially. So therefore, we feel that there is a relativity between the global warming and the natural calamities. And I presumably feel the tsunami and the earthquake could also be related with the global warming and the greenhouse gas. If we all can mitigate the greenhouse gas emissions through the solid waste dumping, open dumping, and through the efficient management of the controlled solid waste management program like biofuel recovery, landfilling, not even landfilling, the best way of, because when the carbon comes into, if the carbon is completely converted into energy, then the path of CO2 is become very, very less, because most of the fuels are used in the process of automobiles, and therefore the CO2 emission is less. So that is what I normally consider and make a small relativity hypothetically between the greenhouse gas emissions, global warming, and the natural calamities. You can see how the sea level rise have taken place. You can see the problem of global warming and the CO2 emissions from various fuel sources. So therefore, I intend to say whatever the waste management practice have to consider the greenhouse gas emissions, have to consider the consequential problem of the greenhouse gas emissions, because greenhouse gases, it warmer the oceans, melting the snow ice, and changing the conditions of the plants and animals, and more drought and wildfires occurs, more precipitation in some places because of the greenhouse gas emissions, and stronger storms, stronger wind, stronger cyclones, and rising sea levels, and the earth absorbs more energy. So therefore, there is a lot of other imbalances happens in the energy budget. And that is what the importance of the greenhouse gases and trapping this energy. So therefore, we have to balance the emissions of the carbon dioxide and protecting the earth through a balanced system. So the CO2 emissions from the combustion process, and the CO2 emission from biogas combustion, it is very relatively very, very low when we compare the CO2 emission from biogas, because ultimately somebody might feel that we are producing carbon dioxide, we are producing methane, and the methane during the combustion process, it is converted into carbon dioxide. How do we say it's a carbon neutral or carbon negative technology? But when you replace the coal, because the burning of the coal releases 1 kg of the coal, stoichiometrically 1.6 kg of CO2. But if you produce a biogas, 1 meter cube of a biogas or 1 kg of a biogas is almost equivalent to 1.5 kg of a coal. So when you are using the biogas for a combustion engine, IC engine, or for cooking gas, or as a automobile fuel, you are replacing the coal equivalent of 1.5 kg, which is equivalent to 1.9 or 2 kg of the CO2 that you are mitigating. So therefore, indirect benefit of the biogas production from the waste material is the reduction of the consumption of the coal And not only the reduction of the consumption of the coal and the coal equivalent CO2 emission in thermal power plants, we are able to mitigate it. That is what the carbon neutral technology we could achieve. So that is the reason finally I say well into wheel comparison and waste into wheel comparisons. So the CO2 emissions from the combined heat and power project, you all might feel that the biogas production, how efficient is the first question you might have it. I could have good answer on that. And how combustion efficiency can be achieved, I will have a very good answer at the end of it. And how the thermal conversion efficiency is comparatively better in the gaseous fuel than compared to the liquid fuels like petrol and diesel. So we could also discuss something on those issues. This is the CO2 emissions, this is the combustion, gasification, and pyrolysis. We have many techniques, but the CO2 emission in combustion is very high, and gasification is very high, and also pyrolysis is very high. So carbon footprint calculations from electricity generation, from natural gas, from fuel oil, from LPG, from waste oil, then we can compare any renewable energy technology that we are going to adopt from the municipal and industrial solid waste, and then we can compare the carbon footprint. How much is the carbon footprint from these fuel? How much is the carbon footprint from the biogas, from the biofuel, from the biodiesel, ethanol, hydrogen, and methane? How much will be the carbon footprint we could calculate? So this is the certified emission reductions. Probably you all might know. If you look at the waste hierarchy, waste management hierarchy in 2007 by the UK, United Kingdom, they've gone first. Initially, there was a landfill practice they have been making. Then the Landfill Diversification Act came in. When the Landfill Diversification Act, they fixed the composition of the waste should not go into landfill and based on the characters of the waste as a Gateman test of the waste. And then subsequently, they brought Renewable Obligation Certificate, ROC. The Renewable Obligation Certificate came in. It was wonderful. All the waste that landfill diversification, when it was happened, the waste as much as possible should go into renewable energy and converting the waste into biogas and renewable energy. That's what Renewable Obligation Certificate. And later on, the next step, they came into white energy strategy because the waste can be also converted into CO2-free biofuel, like hydrogen, because hydrogen is a white energy of the future and therefore doesn't produce a lot of CO2. Therefore, they brought a white energy strategy. Likewise, in India also, you have landfilling, you have a composting technology, you have an incineration, you have a pyrolysis, you have a gasification, you have so many waste management technologies are in practice. But what we should practice and what we should promote is which technology can fetch you a revenue, which technology revenue coupled CO2 mitigation it can give you the benefit, and that technology becomes a carbon neutral technology. And that technology, that's what I have been mentioning from the beginning. What is the ultimate aim of selecting a technology? What technology you tend to select, and how do you select the technology? Whenever you want the composting to be before biogas or the composting to be after biogas, because that is how we select the technology and take it forward further. So the carbon potential of the city's 1 ton of MSW in Indian MSW, if it converts into roughly 100 meter cube or 85 kg of bio-CNG with the 12,000 kilocalories per kg, how much carbon credit it can? So roughly 2,146 carbon credit per day. So you can convert per month and per annum 365 days. 1 ton of MSW can make how much of carbon credit? This is where we are looking for carbon neutral technology to achieve. For Chennai particularly, it is 17.5 carbon credit per day. And Mumbai and Delhi and Calcutta, we have certain thumb rule of calculations of carbon footprint, and we do have how to calculate, and we have been explaining it. So now I'm little bit in the introductory side, whether the gasification is good or combustion is good or pyrolysis is good or biofuel recovery is good. Let us look into how the waste composition demands the technology and which composition of the waste demands which technology. And before actually we get into this, I request all of you to go through the solid waste management rules, Government of India in 2016, which is available in the Central Pollution Control Board. A PDF copy is available, and we all must be aware of what is the existing solid waste management rules being practiced at the moment in India. So this is what we look at it as solid waste. The solid waste is of many categories: hazardous, non-hazardous, combustible, non-combustible. and leachable, non-leachable. There are corrosive, non-corrosive. There are many types of degradable and non-degradable, biodegradable waste and bio waste. So likewise, the solid waste are prominently classified as combustible, non-combustible, degradable, non-degradable, and corrosive, non-corrosive, and radioactive, non-radioactive, and hazardous, non-hazardous. Likewise, there are a prominent classification. In that, in the waste category, there is electronic waste, there are plastic waste, there are metal waste, and there are organic waste, and there are bio waste, and there are biodegradable and non-biodegradable organic waste, the papers, rags, and so many other waste materials are the composition of the municipal organic solid waste. So when we look at it, the Government of India is promoted very nicely about integrated waste management park facility. What is called an integrated waste management park? The solid waste need to be segregated at the source. If not, the solid waste have to be segregated at the collection center where it has been collected in a bulk waste. So once it is collected, it has to be segregated as the metals, as the plastics, and so on. And each waste should go into a separate waste management, waste processing center. So the waste is collected, transported, and processed. After processed means the plastic will go into plastic waste processing center. And particularly in Goa, probably many of you, anybody from Goa, has got a beautiful Goa waste management practice, because Goa is the only state I could see Goa State Waste Management Corporation. Because why it is so, unless until we privatize some of the practice, at least a minimum level of the practice, the enforcement becomes a little difficult. And that's the reason the Waste Management Corporation, if it is initiated by every state, and the Waste Management Corporation can take accountability of each bit of waste generated from the domestic, each bit of waste generated from industries, make an accountability, make a data record, make a data source inventory of that, and find out where the fate of the waste, which ton of waste were gone where, which ward waste gone where, whether it is lying idle or it is fat or been dynamically managed or dynamically decontaminated or dynamically processed and made into some other product. All these can be efficiently done, particularly at least for some period of time, if there can be a privatization of the Waste Management Corporation, complete Waste Management Corporation. There has to be a private practice for plastic waste, for metal waste, for organic waste, inorganic waste, biomedical waste, and all these, the collection, transport, processing, disposal. If all this can be linked and given to one private entrepreneur, and definitely within a span of 2 to 3 years, and like a boot basis, build, own, operate, and transfer, and maybe after 4 years, because the India have excellently performed well in the highways and motorways, roads and highways, because every city, every villages are well connected with the highways. It is because the boot system was introduced, build, operate, and own transfer system. The similar system can also be introduced for the waste management practice of the plastic waste, metal waste, and so on, to the private enterprises on a boot basis. Because initially I said PPP is not a public-private partnership. PPP is a profitably preventing pollution, is called PPP. So therefore, if we wanted to create a COVID-free society, if we wanted to create a dengue-free society, if we want to create a disease-free society in the future, and we must have an efficient waste collection, transport, processing waste efficiently, and disposal mechanisms in a very efficient way, that's going to make us very disease-free living in the future. So you can see here some of the waste, how it is collected. So we all must be familiar with the Solid Waste Act 2016, and we must know what are the environmental health problems related to solid waste, and the method of treatment: landfilling, incineration, open dumping, land or sea, composting, grinding or adding to the sewage, and recycling. And integrated waste management is the system that we need to know about. The Solid Waste Disposal Act, it was very old and brought in Waste 2016, Waste Management, Solid Waste Management 2016, have incorporated every items and brought back in a very nurtured way to improve the disposal technology, to improve management practice, to support research to new approach for handling solid waste, and to support training program and federal assistance to achieve. Because why I say we must support a training program, because if all the municipal commissioners and all the joint commissioners all the municipal engineers, all the city engineers are well taught on how this solid waste management technology can be effectively achieved, then the percolation of the technology to the root level becomes very easy. And that's the reason around 2 years back, I've conducted a waste management technology training in our institute, laboratory training as well as in-house class training, and also field visits for 124 municipal commissioners and municipal engineers of Government of Tamil Nadu. And since then, the Government of Tamil Nadu, most of the municipal engineers, they attended, almost 144 people they attended in our institute, and they all have benefited greatly about how this waste management, particularly waste into biofuel, how effectively it can be done, what are the bottlenecks in there. And it was a 3-day training program we have organized for all the commissioners and municipal commissioners of the Tamil Nadu, Government of Tamil Nadu. And now I request most of the faculties who are from various parts of the country can take forward this kind of training program for the municipal engineers, municipal commissioners, joint commissioners, and train them what is the advancement of solid waste management technology and what are the technology available, what is called the profitably preventing pollution technology, and how that could be effectively managed and effectively implemented in every part of the state. And I hope there are participants from various states in the country, and every state must have a solid waste management training center in any academic institute. And that academic institute, if you need any of the material and what all should be the content of the solid waste management course and what all should be the content of the training program and how effectively it can be organized, I'm so pleased and so happy to help any of the faculty from any state wanted to conduct a solid waste management training program to the commissioners and municipal commissioners that will reach to the very grassroots of the society and what kind of an effective waste management system that we could make it. So solid waste, the sludges is also a solid waste, and because it comes from the sewage treatment plant. And there are a lot of hazardous and non-hazardous waste, biodegradable material. In waste material capable of being broken down by biologically or biological enzyme, it's called biodegradable. Of course, what is called garbage. And industrial waste, the source reduction is one of the very efficient method of making the best possible reducing this waste into become a waste. So because when I was in England for doing my PhD for 5 years, I literally felt there was a market called the flea market, FLUW, flea market, and there was a cardboard sale, and you didn't find, so far I haven't been able to find any old material sale market. And the flea market are, of course, the old car selling market is prominent, I've seen, but not like a e-waste or like a computers. Old e-waste market is not been generated. So therefore, if all the waste materials in a day of a month can be, particularly e-waste can be second use, can be put into one place and resell it to those who are in need of it, and the people can take it and process it and modify a little bit and they can reuse it. So therefore, waste reduction at source is one of the important systems that we must follow. The leachate from the landfill is a very important problems to be addressed. And of course, municipal solid waste. And I hope all of you, because why I said the municipal engineers and municipal commissioners training program is one of the very important concept that we must achieve. Most of the cities, the per capita waste generation, whether it is 0.4 kg per person per day, whether it is 0.3 kg or 0.6 kg or 0.8 kg, what is the actual per capita waste? And because for liquid wastewater, the per capita water generation is available everywhere, because the Metro Water and the PWD and the municipalities have taken very efficient role in the developing underground drainage system and also making the sewage treatment plant efficiently functionable. But for the solid waste, many of the cities are not having proper data on what is the exact per capita waste generation of a city, per capita organic fraction of municipal solid waste generation. Most of the cities are not having the exact data. So therefore, it is the training program can not only fetch you as a teaching and dissemination practice for the municipal engineers and commissioners, but also if you can guide them how to conduct a waste collection, waste inventory survey, that's called a source emission inventory survey of the waste from door to door, and arrive at how much is the per capita wage generation in a particular city, what was the data existing before, and what is the lacuna, what is the mistakes in the data of every city, if you can find out. And that is the wonderful data. Every city can have a waste framework, waste network data center. That's what it is available in England. Every city, how much is the waste goes into landfill, how much is the waste goes into composting area, how much is the waste goes into e-waste management practice, how much is the waste goes to biogas, how much is the waste goes to a composting plant. It all has an accountability, and that can becomes a very efficient waste management system. And that is what the training program can also be part of it. And of course, the recycling, refuse, of course, there is a lot of refuse-driven fuels are being produced, briquetting, refuse-driven fuel, using the sludges and the solid waste for road construction and building construction, low-cost construction materials. Many kind of waste being practiced in many ways. The sources of solid waste: agricultural waste, mineral waste, industrial waste, and municipal waste. And of course, the EPA Solid Waste Management 2002, type of waste: food waste, plastic waste, woods, rubber, textiles, metals, yard waste, and paper waste, and others. So you can see it prominently. 30% is the waste is paper, food waste is 14%, plastic is 12%, wood, rubber, and textile is 14%, metals are 11%, yard waste, agricultural waste are 9%. And you can see total MSW generation by materials 2008, 250 millions. You can see food scraps, yard trimmings, wood, rubber, paper, glass, metals, and plastics. So these are the waste composition, and it's before recycling and after recycling. And this before recycling and after recycling, how the MSW generation is growing every year, you can see here. And you can see how much is the total MSW generation. So there are chemical hazardous waste and non-hazardous waste. Of course, the treatment and disposal methods are sanitary landfill methods, and there are engineered landfill methods. So it is the most economical if land is available in a reasonable price. But however, if the waste contains more organic material, I would prefer a biofuel recovery or any other material recovery. Then the sludge, if it is highly toxic, if it is because toxemia, it doesn't work well in the biofuel system. And then the sludge can go into a manure, and you can make it together with the compost, and the compost can be used for agricultural manure. So sanitary landfill, what are the disadvantages? Requires top daily cover, which might be costly. Water and air pollution, breeding places for it becomes a mosquito breeding places, and therefore it all. You can see how the landfilling system is a methane to be flagged from the landfill, and the groundwater monitoring, how the groundwater mitigate groundwater contamination potential because of the landfill, whether the barrier, landfill leachate barrier, is adequate enough to prevent the leachate or not. And approximately every groundwater near the landfilling area is definitely to be tested and followed, whether the leachate contamination has polluted the groundwater or not. So it's a sanitary landfill, and this is a sanitary landfill, and it's also a sanitary landfill, and dump conversion into a small leachate collection point and making it. And next is incineration, because in incineration, the temperature needed is something like 1600 to 800 degree temperature is needed. That's the major bottleneck when we go for. Of course, for biomedical waste, there is no other way other than to go for an incineration or autoclaving method, and that's what's been followed now. And advantages can be very efficient, decreased waste volume, can be located close to residential areas, safe transportation costs, sources of energy such as steam becomes useful for them. Disadvantages: it's a huge air pollution it generates. Ashes must be considered hazardous waste due to high contents of metals. Of course, we have fluidized reactors to collect all the flue gases, and the sulfur recovery system. All these are prominent these days, and the high capital investment, expensive to operate and maintain. So a small incinerator, you can see the steam is generated. The steam can be used for elsewhere. Open dumping is all too common, and we should not practice it open dumping these days, because the legacy waste management, the waste which is already been dumped over hundreds of years, that's called a legacy waste. The legacy waste management, if all broken and taken these waste management through a biomining system, because nowadays most of the cities, they got a beautiful biomining system management. It's all well practiced, and they convert most of the waste into manure, and the biomining becomes very attractive technology these days. Open dumping, it's of course illegal and optimum for breeding of rats, insects, and so on. And fires, air, and water pollution is the problem. Because composting is a controlled biological decomposition of organic solid waste under aerobic conditions. There are in-vessel composting, windrow composting. There are many types of composting technologies available, and micro composting. Particularly in the government of Tamil Nadu, most of the district you would find micro composting practice. And of course, in Goa, I've seen a very good micro composting. Of course, Maharashtra, Madhya Pradesh, they got a beautiful micro composting technology as well. The composting needs air because we need to completely aerate it to avoid fouling odor and to convert high oxygen input for aerobic degradation. Of course, water to avoid the higher. We have to trap the water because the heat produces water, and condensed water we need to trap it and take it out. And what to compost? Grass, lawn, clippings, hay, kitchen waste, leaves, manure, straw, weeds and other garden waste, wood chips and sawdust. You might ask me why we should go directly this into a composting unit. Why not we go for a biogas plant? And how do you prioritize which technology should go? But in my opinion, I would say even the rice straw and the wheat straw, which is highly cellulosic and hemicellulosic waste, the first prioritized technology, I would say biofuel production, because there are a lot of technology from the rice straw and wheat straw into ethanol, wheat straw into biogas, wheat straw into so many other material, so many other biofuel. Therefore, I would say the biofuel conversion could be one of the very effective technology. And because the stubble waste management, as you all know, the Delhi's air pollution problem partially also contributed by the stubble waste elsewhere. And it's been flown into the Delhi, and the stubble waste management also contributes high quantum of urban air pollution problem in Delhi. And the stubble waste should not be burnt. And if we can make an alternative technology of biogas production from stubble waste, because we have been attempting a lot of work on cellulosic and hemicellulosic hard waste, because the cow dung based biogas production is not such a big advanced technology. The food waste into biogas is not an advance, but the biogas from leather solid waste and biogas from these other solid waste are an important culprit of contributing such a high biogas production. Therefore, these need to be avoided. Sean, I will call you in 10 minutes. So for these to be avoided, and we must encourage the biofuel production technology before the composting, and after the biofuel production, whatever the residue comes, we must have a filter press and filter it, form a cake, and the cake can go into composting along with the general compostable material like grasses, like hay, or any other waste materials. So this composting, it's a brown category compost, we all know. Green categories, a fresh and often green plant materials such as green weeds from the garden, kitchen, fruit and vegetable scraps, green leaves, coffee grounds and tea bags, fresh horse manure, etc. have more nitrogen than brown. So that's what is a waste. What not to compost? Chemically treated wood product, human waste, meat, bones, and fatty food waste and pet waste cannot be composted. So composting systems: 1 bin system, 2 bin and 3 bin system, rotating or tumbling system, sheet or trench system, commercially available bin system, in-vessel composting system. There are many kind of windrow composting system. The rotating or tumbling system is called windrow composting system. So the 1 bin system is called a micro composting system. Perhaps the vermicomposting becomes one of the important technology in the recent past, but the vermicomposting have not been well adopted because of the high rain condition. It get washed off, and the worms production is not adequate during the rainy season. Grinding and adding the sewage in an acceptable method of garbage disposal, it is recommended from the convenience and public health standpoint, but the disposal of other refuse remains to be handled. So that's what it adds to the BOD load of sewage treatment plant. Hog feeding. Pyrolysis, of course, as applied to solid waste, metals and grass removed, is an experimental thermochemical process for the conversion of complex organic solids in the absence of added oxygen to water, combustible gases, and carry liquids. Dumping at sea, probably this is one of the very dangerous problem in these days. Many of the shops and many of the beaches, they dump a lot of garbage into the sea, which affect the aquatic ecosystem. Open dumping, and how the salvaging in the national geography they bring floating trash and national waste, how you can see in the sea, how these waste are floating there and making, we need to make it. So of course, finally, I've come into recycling. It's a source recovery method. That is what, and the ultimate goal of my topic, I'll come in another 5-10 minutes. I'll be able to start. It's a resource recovery method from these solid waste as biofuel, because that will attract the future, that will attract the profitably preventing pollution-based technology in the future. So therefore, this is the waste, and these are some of the e-waste management. It's very, very good, and people must concentrate all the computers and the electronic waste like mobile phones, cell phones, and telephones, and so many electronic goods. When it is condemned, it needs to be saved practically. Particularly the phones which contains batteries are to be managed very safely and efficiently. These are some of the e-waste management practice. You can see here chips and boards, temporary boards of electronic circuit boards are put into collected and used and separately generated e-waste. It's harmful to human health, and they take out the chips and they can use it elsewhere. So of course, some of the recycling bags, recycling of the materials. So this becomes like auto batteries, office type papers, steel cans, yacht trimmings, all this has the problematic things. So now the reduce, recycle, incineration and the landfilling system. So this is what now we are actually going into the biofuel recovery system, and production of biofuel, production of other biofuel technology, which is the actual core of my R&D topic for the past 30 years of my CSIR surveys. And I would be very happy to present what I have been doing on the biofuel recovery, and what I've shown to you now, how this municipal solid waste are being effectively managed, and what are the system adaptability we must be able to introduce into the Indian waste management practice. Yeah. So these are the biofuel recovery technology that I have implemented throughout my career. And this is the 2 tons per day biogas producing technology for electricity production from the leather solid waste. And this is in Melvisharam, Rodipet, and this is the biogas production technology for slaughterhouse solid waste at Hind Agro Industries Limited at Aligarh. And this is the 60 tons per day slaughterhouse solid waste into biogas into electricity plant at Alkabir Exports Limited, Hyderabad. And this is for the production of biogas and electricity using the slaughterhouse solid waste. And again, this is the Coimbatore biogas plant at Coimbatore, and this is for the vegetable market complex waste, because in India we have a very big vegetable market complex waste, and that vegetable market complex waste is Asia's biggest vegetable market. You all might be knowing that's in Coimbatore place in Chennai, and we produced around 30 tons per day of the vegetable market used in biogas plant after mincing, after shredding, after pulping, and we fed into the digester along with the sewage treatment plant sludge, and we produced biogas and electricity. And this is again the biogas production from the tannery solid waste. This also biogas production from tannery solid waste, and this is the chromed leather shaving waste, because most of you must be thinking that tannery means chromium is the problem. Of course, this is the chrome bearing leather solid waste. We call it chrome shaving waste. We have gelatinized. We have converted the chrome bearing leather solid waste into gelatin and other chrome cake as chromium sulfate, basic chromium sulfate. And the basic chromium sulfate was used in back in the process after recovering the basic chromium sulfate from the chromed leather shaving waste. And the gelatin was used in the biogas plant to produce biogas. And once it was attempted to produce biogas together with the treatment plant sludge of the tannery, and now this gelatin, because that was the technology advancement, the gelatin nowadays they use it as a commercial grade gelatin, commercial grade protein, and the people are using it for commercially selling the liquid protein. And then we shifted to the treatment plant sludge based biogas plant. Like, so that's what, when we put up a biogas plant, it continues to emerge and the technology becomes obsolete and other waste management system can be practiced using the same biogas plant. This is the biogas plant for food waste, and probably this is what the technology changes. This is the mixing is the difference in this biogas plant between these two. Here is the gas mixing. Here is the funnel-based, centrifugal-based, recirculation-based mixing, and this is again a gas mixing. This is also a gas mixing, and this is the horizontal gas-induced mixing, and this is the impeller-based mixing, a small rotating impeller-based mixing. Although it's an expensive, and later on we replace the impeller-based mixing into a gas mixing. And I've been doing this as a consultancy project for the Tata company in Devas in Madhya Pradesh. That is to produce biogas and electricity from the leather solid waste of Tata company in Devas near Indore. And so these are the technology that we have done. And this is the biogas plant at Melvisharam. You can see it's a 2 tons per day biogas plant. You can see how this gas is flaring and it's brightly combusted at the top, just to show we have combusted and made it. But otherwise, the gas is purified. The hydrogen sulfide content in the gas is eliminated and used in the dual fuel engine. This is the dual fuel engine room where the biogas is in a dual fuel engine with the diesel of 70:30 ratio. We mix it and produce electricity. And of course, the dual fuel engine becomes a very Herculean task later on based on the consumption of diesel. And straight away went for gas generators without using diesel in the later technologies. And directly we produce biogas using gas generators for electricity. And this is the digester. The biggest part of this technology is there are funnels on the top. Because this is the vertical anaerobic digester, this is also a digester. The funnels at the top will collect all the foam, froth, and scummy material. It brings down to the centrifugal pump at the bottom. The centrifugal pump is operated and it is rotated in a heavy agitation mode, where the foam and the scrum and the frothy material comes to the centrifugal pump and broken and delivered at the bottom, where the gas is escaped with the buoyancy to the gas holder nearby. This is the gas holder, biogas holder, and the slurry and the solid waste and the biomass is stayed back, retained back. So, like this upflow anaerobic sludge blanket reactor, you all would have heard of it. What's very important is the gas liquid solid separation in any anaerobic system. If it is a solid waste management system, the gas liquid solid waste management, gas liquid solid separation is very efficiently to be managed. Otherwise, we won't get adequate gas production. But of course, any solid waste, when they put into a small digester, definitely there will be a minimum quantity of the gas produced. But it doesn't make a sense of a revenue-based technology. But that is the reason nowadays, whenever we go for a biogas plant or a bio-CNG plant, the prime thing that we look for is payback period-based technology, bank guarantee-based technology. So nowadays, people are taking a lot of loans and they are going for bank guarantee-based biogas technology. So that is what the people are looking for, the technology where per ton of the organic fraction of municipal solid waste, minimum 80 to 100 meter cube of biogas should be produced, not only 40 meter cube or 30 meter cube, because many they say, actually it is not for the waste disposal problem, it is for the revenue generating problem. That's the reason the technology should fetch a high quantity of the biogas out of the each bit of solid waste. And this is the Melvisharam solid biogas plant. This is the waste dumping yard, and there is a mincer here. It is a mechanical mincer. It minces and make like a paste and admixed with the C-Trichy primary treatment sludge, and both put together and fed into the anaerobic digester. This is the hydrolyzer, and this is called methanizer. The hydrolyzer, whatever the solid waste is put inside, are converted into volatile fatty acid, which is a precursor for methane production. And then in the first stage of hydrolysis is only a solubilization or liquefaction process, where a part of the enzyme is added, protease or lipase enzyme is added, where these enzymes convert this organic solid waste into a liquid fermentable volatile fatty acid. And that volatile fatty acid of the liquid, when we feed the next day, because of the high density of the fresh feed, it goes and settles the bottom, and it displaces the liquid equivalent quantity of 2 meter cube or 2 tons per day, and that goes into the secondary digester called methanizer. So the methanizer, the substrate is volatile fatty acid. The volatile fatty acid is completely converted into methane in the methanizer, and the methanizer produces methane, and the methane goes through the gas pipeline into the gas holder. And you can see the gas holder, the condition at the top. The gas holder is designed, the engineering design of the gas holder is such a wonderful task. It has got a breather valve at the top. And the breather valve is like a cooker in the home, like a rice cooker. Whenever the gas pressure is more than the designed pressure, the cooker whistle of the cooker or the top portion of the cooker will automatically open and release the gas, and it doesn't make any safety problem in there. And that is the design of the digester. It's a bell and shell type. The bottom is the liquid and just the water is filled, and the gas comes into it and filled to the bell on the top. And the bell, when the gas is pumped inside, gas is flown inside, and it starts floating and goes to the top, and until it hits the its own designed pressure release system. So this is the biogas plant existing at Melvisharam. Of course, it was a very successfully operating plant, because the bottleneck of this technology normally, that's the reason whenever we go and put a biogas plant, the solid waste of leather flushing was used for the biogas plant until the plant was demonstrated and made successful operation. And due course of time, the solid waste were shifted to other product recovery of glue industry, because these ternary solid waste contains a lot of protein, a lot of gelatinous material, a lot of fat material. The resource recovery became very prominent there, even then the biogas plant. So the glue industry fetched all the solid waste of the tanneries. And again, most of the glue industries are closed now. They are coming back to the biogas system. And that is how the hierarchical waste management is being disturbed or rather practiced. And this is the slaughterhouse solid waste biogas plant located in Hyderabad, in Rudraram in Medak district near the Hyderabad. And it is well operated, 6 crore worth of a biogas plant. This is the gas holder, this is the digester. The beauty of this is the Bima digester is a biogas induced mixing arrangement digester. No impeller, no mechanical component inside. As soon as the gas is pressure is built at the middle chamber, and the outer chamber liquid goes out, and finally when the pressure is released, the gas released to the gas holder. When it is released to the gas holder, whatever the pressure release hydraulic pump have taken place at the middle, and again slushed back and create a slushing mechanism inside the digester. And that's how this is made. And this is the gas holder, and this is the digester. Bima digester is one of the very versatile, interesting technology these days. And because it has got a biogas induced mixing system rather than a centrifugal based, which I've mentioned before, rather than a impeller based mixing. Because I think most of the chemical engineers or most of the mechanical engineers are very good in computational fluid dynamics, where the biogas mixing, where the impeller mixing could be well studied, and design the digester based on the computational fluid dynamics based, rheology based gas mixing system. That is what, in fact, my wife did a PhD on computational fluid dynamics based biogas mixing system for anaerobic digester, and how to design a gas mixing system. What should be the injection velocity, what should be the bubble size, what should be the pore size, nozzle size, and how the effective turbulence or the effective mixing can be achieved at very good optimum rheological conditions. And that's what she did a PhD program together with me in this system of biogas technology revolution. So this is the Tata company biogas plant, again the hydrolyzer and methanizer, and how the technological revolution we have made. You can see here the length by diameter ratio was 1.6 and 1.5, and perhaps you can see here the length by diameter ratio becomes 1. And that is what the engineering design innovations that we have made. We have learned whether the gas mixing is worth, or the impeller mixing is worth, or the centrifugal mixing is worth, what should be the dispersion number, Peclet number, residence time distribution analysis of a digester, and computational fluid dynamics part of the digester, and how we should design the digester based on the RTD, based on the computational fluid dynamics properties of the rheology system inside. And that is what, because as we increase the loading of the solid waste into a high rate digester, and these anaerobic digesters are classified as high rate, standard rate, and low rate digesters. What we call a high rate digester, a high organic loading rate or high solid waste are fed into a shorter retention time. So when we are feeding into a high rate digester with a shorter retention time, obviously what is more prominently a problem is the mixing becomes a problem, viscosity becomes more high inside the digester, and the rheological properties becomes improper for the high biogas production. Therefore, we work on the RTD, residence time distribution analysis. We work on the dispersion number. We work on the Peclet number. We work on the computational fluid dynamics part of it to design the appropriate digester based on the desired organic loading rate and the engineering kinetic constants of the digester. So this is the co-made biogas plant for the 60 tons per day of the co-made vegetable market complex waste, and the waste is collected and put into here, and there's a rope. It collects the waste from the dust from the bin, and the bin brings into the conveyor. When the waste is put into this conveyor, the metals, which is a heavy weight, and goes back and collected at the metal trapper, and the organic waste goes into the mincer, and the mincer is mincing, pulping, and it gets liquefied and added with the sewage treatment plant wastewater, and both mince together, pulp together, and homogenize together, and put it into the digester, melt of the digester, because it's a Bima digester. And when it is hydrolyzed, and slowly the hydrolyzed product comes into the methanizer, which is an outer digester, and where the methane production is done, and it gets converted, it's scalded in the biogas storage tank, and then it is used for electricity production. And this is a small mincer, you can see here, and this is the mincer. The mincers the solid waste, particularly other solid waste, and into a small size without much electrical cost involved. And this is the mincer, and this is our biorefinery plant, because I've been telling from the beginning, instead of producing one fuel as a biogas, because leather solid waste contains a lot of fat material, fatty material is there, because the fat and can be converted into oil, the oil can be transjustified into biodiesel, and that is what we have used the fat content of the leather solid waste before disposal, and we have used it for a transjustification process. And this is the biodiesel plant that we have built for Ranipet in Vellore district. There is a Ranipet common effluent treatment plant system is there, and that's where we have introduced the biodiesel recovery plant, followed by biohydrogen, methane, and ethanol plant, where you could see here the digester construction is going on, and almost it has completed. Last week I've been there. This is the hydrogen plant, and this is the methane plant, and it has been built well, and probably the recent photos I have not been able to take it. And now we are going to commission the plant of producing ethanol, hydrogen, and methane, because we have seen already the biodiesel. The residue of the 2 tons per day is the tannery solid waste we'll be using. The residue of the biodiesel plant will be taken to a bioethanol plant, hydrogen and methane plant, and the final residue will be taken to a filter press, and where the filter press, the cake will be converted into fertilizer, agriculture fertilizer, and the liquid will go back into the common effluent treatment plant. And these are some of the studies where I did, because mostly we do a lot of pre-feasibility study. It's not that we straight away prepare a detailed project report, DPR, or the design configuration or the engineering details, straight away prepare for any waste into any biofuel recovering technology. Primarily, we will be doing it with a laboratory study on bench scale study, and a little piloting study on 10 liters per day, 100 liters per day. And then we understand what is the feasibility of producing biodiesel, ethanol, hydrogen, methane per ton of the solid waste, and what engineering configurations are required. And then we prepare a detailed project report and give it to the client, that your waste of total waste of say 100 tons or 50 tons will be yieldable this range of biodiesel, ethanol, hydrogen, and methane. And that's how we prepare a DPR based on the pre-feasibility report, pre-feasibility study done in the lab. And these are all the pre-feasibility study report reactors. And this is like hydrogen and methane reactors for a pre-feasibility study. And this is what the biorefinery is to achieve: biodiesel, bioethanol, biohydrogen, and methane. And we have a pilot plant also in the laboratory. And for anybody in need of it, we conduct a pre-feasibility study using the pilot plant. And this is the biorefinery plant. So tannery solid waste, either through autoclaving or either through thermal recovery or through enzymatic method, we collect the fat oil. And the fat oil, it contains fatty acids like oleic acid, linoleic acid, palmitic acid. All these fatty acids are there. So the free fatty acid, total free fatty acid, is the major controlling parameter here, where if the FFA is very high, then we go for a 2-stage transjustification process. If it is very low, then we go for a esterification process and convert into biodiesel and used in petrol pumps after purification. Because purification of biodiesel, because while doing biodiesel, it contains a lot of solvents, and the solvents need to be purified and taken off. Otherwise, the fatty acid ethyl ester, which is a biodiesel, or a fatty acid methyl ester, the biodiesel will be intact in there. So that's how we try to eliminate in here after purification. And then the bioethanol, whatever the residue it contains, the residue goes into a bioethanol plant with the standard seed sludge. That's an innovation of our bioethanol plant. We prepare seed sludge for the solventogenesis process, and not for the cellulose or hemicellulose rich waste, but for the acetic acid or ethanoic or butyric or propionic acid waste fermented into ethanol or acetic acid, and then the acetic acid into ethanol, and that's a bioethanol plant. The seed sludge or the seed inoculum that we prepare for particularly for this is one of the novel method that we adopt. And then after the residue of the bioethanol, whatever it comes out, and that we use it in the hydrogen plant, where we produce biohydrogen, and then the residue of that we produce methane plant, and that's how finally we filter it and convert into a solid fertilizer. So this is the biorefinery plant, renewable energy product, and biofuels, biodiesel, bioethanol, biohydrogen, and biomethane are the product for energy, economy, and environment, as I mentioned initially. So this is the typical Ministry of Environment and Forest 2 tons per day biorefinery plant. It's a 1.1 crore project, a pilot plant, and we have built a demonstration plant at Ronipet. And this is the tanneries. They have 70 tanneries. We collect the solid, not from all 70 because it's only a pilot plant. Almost around 100 tons of the waste is generated, but we are using only 2 tons as a demo plant. And that tannery solid waste, we collect it and wash it and clean it and take out all the dung and other materials in there. And then we take it into a heating enzymatic tank to hydrolyze and collect the fat oil. And then use the fat oil in the biodiesel trans-esterification tank and convert the fat oil into fatty acid methyl ester, which is nothing but the biodiesel. And then that will be taken for a centrifugal tank for purification with a water wash and to take out all the solvents, excess solvents or excess alcohol in there. And then afterwards, we send it directly to the petrol pump. And then they can blend it B20 or B30. They can use it in a various generators or directly into the petrol pump at various blending ratios with the diesel, alkyl diesel. Then the residue goes into the ethanol plant, where the ethanol plant produces ethanol. As I told you, it has got a specific seed inoculum, where the ethanol solventogenesis process we adopt in the lab and make it a perfect ethanol recovery system. And that is fed into ethanol is fractionated and collected and distilled and taken for petrol pump. And the residue is taken into a hydrogen plant. So the biohydrogen plant produces biohydrogen, and then the hydrogen is taken for purified and taken for usage. And then the methane plant, it produces methane, and the residue goes for fertilizer production. So this is in the trans-esterification reaction, particularly what is more important is the molar ratio of the ethanol and system. Molar ratio is very important. Catalyst concentration, KOH, concentration, optimum dosage is very important. Temperature of the system to recover maximum biodiesel is important. Stirring speed and viscosity of the liquid, and reaction time, of course. All the important operating parameters, influencing parameters for biodiesel recovery. And this is the methodology, is extraction of oil and fat. It's a small fat recovery system where we use it to recover the fat oil, and the fat oil is used for trans-esterification to convert into biodiesel. So this is a various method of optimization. This is a various method of optimization, and this also temperature and other methods that we have optimized. And this is what the biodiesel we can separate because the end product is biodiesel and glycerol. The glycerol will be on the top, biodiesel is this, and we recover the biodiesel separately, and then we purify it also. So this is the confirmation test using FTIR spectra, that how this biodiesel can be confirmed with the standard diesel. So this is the FTIR data, and these are the free fatty acid. What are the acids it contains? Maleic acid, palmitic acid, stearic acid, oleic acid, linoleic acid. What are the free fatty acid it contains for conversion into biodiesel? So this is the animal fat, free fatty acid. Particularly palmitic acid is 3.34, and oleic acid methyl ester is 79%. You can see, and linoleic acid is around 12%. So maximum is oleic acid and linoleic acid is the maximum composition in the animal fat. And this is the fuel properties. After the fuel is produced, we test the fuel whether the fuel quality is better or not, and we test the flash point, fire point, gross calorific value, density, engine power ratings, bore and stroke engine. So all these we use it and test it to reduce to understand what is the level of pollution it has reduced. And this is some of the brake thermal efficiency, brake powers versus thermal efficiency we conduct using IC engines, and then we plot various ways. And I had 3 MTech mechanical engineering students, and we had tie-up, and they did their PhD and masters with me, and in which they produced the emission testing characters of all. So this is the total biodiesel plant, and this is our pilot plant where the biodiesel is produced here, bioethanol is produced here, biohydrogen, bioethanol, hydrogen, and methane is produced. This small pilot plant, it has got a wheel at the bottom. It can be transported to elsewhere wherever we like, and we can produce all these fuels for a pre-feasibility or preparing detailed project report for any industries. And this is where we are testing the biodiesel plant. He is Mr. Thambiran, did his MTech project under me for producing biodiesel. Mr. Kandasamy and many other colleagues who intend to produce biodiesel from the leather solid waste. So this is an Ethiopian who wanted this technology for biodiesel production. They did, and this is some of the technical achievements. These are the biogas plant. This is the inauguration of the biodiesel, large-scale biodiesel plant, and this is how we are testing and making the calibration validation of the plant. And these are all the actual biodiesel plant existing there. This is again, I'm in a Zoom meeting. I will call you. So this is the biodiesel plant actually built on the on-site at Ranipet. This is the biodiesel plant. This is again the biodiesel plant. This is the waste, how the flushing waste is there in which we produce the biodiesel. This is a biodiesel plant. This is the fat recovery unit. This is actually the bioethanol plant where we have built. So leather fat oil is taken, transesterification, and biodiesel and glycerol is taken off, oil extraction, and then the residue is taken for ethanol production. So these are the batch studies of conducting ethanol at various operating conditions of pH, temperature, seed inoculum to substrate ratio, and how this control and the bioethanol samples we got. Some of the yeast inoculum also we have added and made. So this is the glycerol versus biodiesel recovery, bioethanol recovery system on the first day, second, third, fourth day. How this ethanol recovery concentration we have reached, you can see 74% and from 0.18%. So optimization of bioethanol process we have done. So this is the optimization of bioethanol in the laboratory we have done. It's the total plan. Of course, this is the biohydrogen plant and methane plant what we have built on site recently. And this is the hydrogen plant. The residue from the bioethanol plant is fed into this hydrogen plant. There is a mixer from the top to bottom. It recycles, and also there's a mixing provision inside. This stirrer mixing is only for startup, and it doesn't operate continuously. Just per day, in case it got choked or it has got any problem in there, that time only the tuning happens. They're turning into a little mixing. Then otherwise the gas mixing and slurry recirculated mixing is the most of the time it is operated. And this is the methane production plant for producing methane. And this is some of the recovery systems. Yes, these are all the tasks that we have achieved on the bioethanol, hydrogen, and methane plant. Thank you very much. And these are all some of the testings that we have made, and we have used our biodiesel in our director's car successfully. We have operated, and we have made the limitations, and we have understood. And finally, we have been able to demonstrate this plant even for Ganga Action Plant, the solid waste management at Kanpur. We have taken both sewage sludge and the solid waste of tanneries. This plant has been shown and demonstrated to our Honorable Prime Minister at Vigyan Bhavan in New Delhi. And this is the tanneries, how this biogas to electricity, biofuel technology can be adopted as a part of Ganga Action Plan. So this is the plant that we have built, and it was demonstrated to our Honorable Prime Minister. And this was the technology demonstrated about the Ganga Action Plan. So this is some of the award that Dr. APJ Abdul Kalam Best Memorial Scientist Award, I got it, which I mentioned. This is some of the biogas plant at Peterborough in Huntington built. So just I wanted to show you a community digesters for small villages. There can be horizontal digesters where the village people can use it for lighting or street lighting from their cow dung or from their domestic waste. So a community development biogas plant also is possible to build in a very low cost system, not only a hi-fi plant like automatic plant. A small community digester, community biogas plant also can be built and operated successfully for the villages, for the agricultural farmers, for the domestic village of an apartment or elsewhere. And this is what I so see the digester is built very nicely for a cold country by putting all the straw on the inside and outside the concretization has been done. And we can build the digester like this. And finally, this is the digester, horizontal digester, and where you can see the gas holder on the top of it. The digester is closed here completely, horizontal digester. There was a hole and the gas holder was connected on the top of it, mounted here. And then the gas production in a balloon is stored and then taken through the pipe for cooking purpose. So the pipe which was there is connected, even it can be collected through a lorry tire. And then there's a small tube with, you can see the high biogas is burning. And you can use it for cooking purpose in villages. So that's how I really wanted to make to the participants today. And I think it is 12:45 is the time now. And I would like to conclude with my sincere thanks to the participants and also thanks to Dr. Premalata Madam and Mr. Dr. Rupan who have coordinated this program. Thank you very much. Thank you very much indeed. I would like to take some few questions. And of course, anybody interested to take this bio-CNG plant, because now we have got the biogas into bio-CNG plant. We have put up in Abohar, Batinda, Rohtak, in many other places in India. And those who are interested can come forward if you want to conduct training program for the municipal engineers of your state. And if you want to put up a large scale 200 or 100 tons per day biogas bio-CNG plant in your state, I can help you out and coordinate with you to put up a bio-CNG plant for cars and buses. And now I've been involved in the Bureau of Indian Standards to develop a biogas manual, biogas standard manuals on the design, commission, utilization, operation of this plant for as an Indian standard. And I hope shortly in a month or so, the manual will be released and that could be used for the whole solid waste management community on biogas into bio-CNG as an automotive fuels. Thank you. Thank you very much. Thanks for your patient hearing. And thank you for the opportunity to the organizers. Thank you very much.
Yes, sir. Thank you. Thank you for the. It's a very insightful presentation.
Thank you. Thank you. Thank you very much, madam.
Thank you. Thank you very much, sir. Indeed, it was a very detailed and elaborate session. You have shown us a lot of real-time implementation and how far you have taken these biogas plants. You have contributed a lot to the penetration of this technology, and it's indeed very impressive to see, sir. Thank you very much, sir, for your time and
thank you very much.
Wonderful lectures.
Thank you very much, Doctor. Thank you.
Thank you. Thank you.
Thanks.